Weather station models. What exactly is a weather station model? Well, we know in the study of meteorology that there's lots and lots of information to look at. Everything from visibility to humidity to temperature. And communicating all this information can be very tricky, especially considering it's changing on a minute-to-minute basis. And so meteorologists have devised a system of codes and numbers that can take large amounts of data and simplify them to make it easier to communicate. And that's what a station model is. Here's what a station model looks like. Now, you may have seen these on weather maps. We need to be able to interpret these, that is, know exactly the conditions that this station model is revealing. And so what we're going to do is we're going to look at all the numbers and symbols on this and figure out what exactly it's telling us. So let's get started. We'll begin with the center. The center circle on a station model is going to be colored in to a certain extent, and the amount of coloring reveals the amount of cloud cover. In this case, because 3/4 of the circle are colored in, we know it's a 75% cloud cover. We might call that mostly cloudy. On a clear day, the circle wouldn't be colored in at all. On an overcast day, it would be completely covered in. Typically, we'll refer to the cloud cover as a percentage, as you see here. Next, let's look at this odd kind of symbol down at the bottom. This reveals both the wind speed and the wind direction. And let's see how that works. Let's start with the direction. Imagine we had a plane circle here, the start of a station model. If I have a line looking like this, that's telling me where the wind is coming from. So if you think of this as a compass with the top being north and the bottom being south, the left being west and the right being east, then this would reflect a wind blowing in this direction. We would call it a westerly wind, which is a wind blowing from the west. Keep in mind that when we name winds, we name them for the direction where it's coming from, not where it's blowing to. So this wind, shown on this station model, would be a west wind. If the line were over here, it means it's going in that direction, and we'd call it an east wind. We can also have in-between directions like this. It would be going in this direction, and we would call it a northeast wind. Now again, that means it's coming from the northeast. So if we go back to our station model and look at our wind direction here, we would see that it's coming from the bottom left, which means it's a southwest wind, which means it's coming from the southwest. Now, there's more to talk about with wind than just the direction. We also want to know how fast it's blowing. And to do that, we use a unit called a knot, K-N-O-T, and a knot is very similar to a mile per hour. The way we tell the wind speed is by looking at these two, in this case, two markings down in the end, and we call these feathers. These feathers can either be long or short. As you see here, we have one long one and one short one. Now, for every long feather, we have 10 knots of wind speed. And for every short feather, we have 5 knots of wind speed. So in this example, since we have one long feather and one short feather, our wind speed is 15 knots. If you have an in-between wind speed, 16, 17, 19, 11, things like that, for our purposes, we'll just round to the closest 10 or 5. Back to our station model. Let's look at the numbers now. The number on the top left corner is always going to be your air temperature, and it's always going to be in degrees Fahrenheit, though we never put those units on the station model itself. Remember, the purpose of a station model is to communicate lots of information, but in a small, simple format. And so we don't bother ourselves by including units, we just simply put the numbers. So keep in mind the temperature, which will always be on the top left, and always in degrees Fahrenheit. Okay? Right beneath the temperature, we'll see a number, which in this case is 1/2. That reflects our visibility. And what that means is how far you can see in the distance before your view becomes obscured by cloud cover or the other components of the atmosphere. It's always going to be measured in miles. And so in this case, we have a visibility of 1/2 of a mile. Next to the visibility, there will be some sort of symbol. And the symbol tells you what the present or current weather conditions are, if there are any. Now, in order to figure out what each symbol means, you would need this table, which is found in your Earth Science reference tables. And so if you look, we have different symbols for different things, from drizzle to rain, smog, thunderstorms, haze, etc. Now the symbol that we see on our station model reflects snow. So that means this location is currently experiencing some snow. What about in the bottom? Well, this number on the bottom left corner is going to be our dew point temperature. In this case, it's 27 degrees Fahrenheit. Just like the air temperature, this is always going to be measured in degrees Fahrenheit. Now, there's one thing I want to point out about that, and that is that the closer together these two numbers, that's going to reflect a higher humidity. And that's important to note because relative humidity is not a number that's included on the station model, though it can be inferred using the temperature and the dew point. So keep in mind, when these numbers are close together, that reflects a higher humidity. If they're farther apart, that means it's less humid. In the case of the example we're looking at here, we can see that it's fairly humid on this day, being that there's only a 1 degree difference between the temperature and the dew point. Moving on the bottom right-hand corner, you may see a number, and that's going to reflect the amount of precipitation, rain or snow, that has fallen during the past 6 hours. In our example, there's been 1/4 inch of precipitation. Finally, to the last two numbers. These are going to relate to our air pressure, or our barometric pressure. And these are probably the trickiest numbers to decipher on a station model. Let's begin with the actual pressure, which is the number on top, in this case 196. Now, to measure pressure, we use an instrument called a barometer. It measures barometric pressure, which in essence is the amount that the air is pushing down on you on the surface of the Earth. Now let's go through an example here. A typical pressure measurement, for example, the one we see on this barometer, might be something like 1,014 millibars. Typically on Earth, the pressure is going to range from about 950 millibars up to about 1,030, 1,040 millibars. So 1014 is certainly a typical pressure that you might see on a nice day. The problem is this is a big, bulky number. It's got 4 digits, a decimal point, 1 decimal place, and units. And remember, we're trying to save space on our station model. So meteorologists have come up with a system of coding or shortening the air pressure to save space on a station model. Now, if this were my air pressure, here's what I would do to code it. First thing you're always going to do is get rid of the units, because remember, we don't use any units on a station model. So you drop your, in this case, MB, which by the way is millibars. Next, what we're going to do is we're going to drop whatever the number starts with. And you have two choices. It's always going to start with either a 10, like in this case, or a 9. And so whether it's a 10 or a 9, you're going to drop that. So we're going to go ahead and drop our 10. Now the last thing is, we're always going to be going to 1 decimal place, so we don't need to include that decimal point. We know it's there. There's no need to actually waste the space and use it. So let's get rid of that decimal point. And so what we're left with is 140, and that's the number you would actually put onto your station model. You see how it's much shorter than writing 1014.0 millibars. Much simpler. Let me give you one more example of how to code air pressure. Here I have a slightly lower one, so this might occur on a stormy day. 973.2 millibars. Now remember, to code this, we want to shorten it. So I'm going to start by getting rid of my units. Now remember, we said we also have to get rid of what it begins with, which will either be a 10, like in the previous example, or in this case it would be a 9. So we can drop our 9. Then all we have to do is drop our decimal point, and we're left with 732, and that's the number that's going to go on our station model. So if we go back to our example says 196. So we have to figure out what that actually is in the full version. So in this case, instead of shortening, we're lengthening. We want to know what this number is. So we have a very simple rule to convert this. And the rule is this. If the number on the station model is less than 500, then you're going to add a 10 before it. If it's greater than 500, then you're going to add a 9 before it. So our number in this example is 196. And that's certainly less than 500, so we're going to go ahead and add a 10 before it. But don't forget, we also have to add a decimal, which will always be right before the last digit, and a unit on the end, which will always be millibars. So when our station model says 196, we know that that actually means we have an air pressure of 1019.6 millibars. Let's not forget about the final number on our station model. Just beneath the barometric pressure is something called the barometric trend. Now, as we learn about weather, we will see that what the air pressure is doing signifies what's going to happen with the weather. So, for example, when the air pressure is dropping, that's a sign that bad weather is approaching. When it's rising, that's a sign that good weather is approaching. And so knowing what the pressure is doing is very important. And so we include the barometric trend, which is just that. It's a measure of how the pressure has changed in the past 3 hours. So in this case, this plus 19 with the slash going up tells us that the air pressure has increased by 1.9 millibars over the past 3 hours. The reason I know it's increased is because I have this plus sign here. Had the pressure dropped, that would be a negative sign. Another thing is this interesting little graph. Think of it as like a little mini line graph. That's telling you the trend. And so you see that the line is going up. That's a vertical trend. It's an increase. Had the pressure dropped, that line would be tilted downwards, showing you a decrease. And so that's how we read a station model. Now, before we finish up, let's look at one more example of a station model and run through and figure out what the conditions are. All right, so here we have it. Let's begin with the cloud cover. It is 3/4 filled, so we have 75% cloud cover. We have a wind coming from the southwest, and it's traveling at 15 knots. Our air temperature is 43 degrees Fahrenheit. Our visibility is 3/4 of a mile. Our current weather is fog. We have a dew point of 40 degrees Fahrenheit. And by the way, it's fairly humid because my temperature and my dew point are only 3 degrees apart. We have an air pressure of 1014.6 millibars. And we have had, well, we don't have the barometric trend listed. So either that information was unavailable or the pressure has simply not changed in the past 3 hours. So I'll skip over that. And the final thing we know is that in the past 6 hours, we have 0.06 inches of precipitation that has fallen. And so that is how we read a weather station model.